All right, I'm going to do the first 5 here for you, just to give you a sense of how this induction works. If you remember our rules for magnetic flux, so if the magnetic flux is increasing, which means the number of field lines are going up, bear with the writing here, then my magnetic field that is original, I'll call that V sub O, and my magnetic field that's induced by the current I create, those two guys are going to be opposite, right? If this is going down, then those two guys are the same. The induced magnetic field and the uh, original magnetic field. Okay, so there's kind of two things you need to do here. You need to figure out where the original magnetic field is pointed, and you have to figure out the is it increasing or decreasing in flux. Okay, so let's go back here, clear up the screen a little bit, and let's take a look. If I'm going to pull this magnet through, these field lines that come out of here, or actually in this case go into the south, right? As this gets farther and farther away, that a number of field lines is going to drop. So this is going to be a drop in magnetic flux. So that means that the original magnetic field, which is pointed upward, okay, upward through the coil, has to be the same as the magnetic field that's going to be induced by the current. So let's pull up my right-hand rule graphic here. And so I need my fingers then, if you can see them here, I need my fingers to point up in the middle of this coil of wires. And the way I would do that is to have my thumb move to the right across the front. In that case, my fingers would then loop up inside, and I guess in this webcam things are kind of backwards, so I wonder if I can do it this way. Yeah, kind of like that. My fingers would be inside that loop of wires with my thumb. You look at the picture on the site here. That means that the current, and I'll do the current with, how about orange? The current will be going then around this way. Okay, and that way when my thumb goes to the right, then I'll have my fingers come up through the middle to match because they're opposite. Okay. All right, on to the next one. It says the current along straight wire is increasing. So that means that the field is increasing in strength so that more and more and more and more and more field lines are now going through that that coil of wires. So in case B, my magnetic flux is increasing. Okay, the strength of the magnetic field next to that coil of wire is getting stronger, stronger, stronger. So the two, the original and the induced, are going to be opposite. Okay, so what is the direction of the current on this side? If I take my thumb and I put it on that wire this way, the way to do that, my fingers then would be going into the page at that spot. Okay, that means I've got X's here. I can do X's. Okay, X's. And as this current increases, the X's are getting closer and closer together, which means more and more fit inside that coil of wires. So in order to follow this Lenz's law, I need the circle to produce a magnetic field that has dots inside it. Okay. Now, how would I have dots? I'd need to have magnetic field coming out of the page, inside the coil. So to come out of the page, I need to have my thumb follow along. Erase this stuff. I need to have my thumb follow along this way, counterclockwise, because then my thumb would wrap up on this side. These are my fingers and my thumb, and they would wrap up on the inside to create dots, magnetic field dots, meaning coming out of the page. Okay? If I went the other way, then my fingers would be on the inside of the circle going down, which would be X's. I want that because Lenz's law said if it's increasing, they have to be opposites. Okay? What about C? The current stays constant. If the current's constant, the number of field lines going through here, the x's, are not getting any closer together. So the same amount of x's are always in there, so there'd be no current. For D, the current in the long straight wire, now I've got the velocity moving this way, so these are all x's. And it's moving to the right, the amount of x's are never really increasing or decreasing. It's not getting any stronger. So that would be another no current answer. For E, this is getting further away. And if you remember, the strength of the magnetic field decreases with the distance away from the wire. So these x's get further and further away. So as you pull this coil down, you'll be decreasing the magnetic flux. So that would be a downward. So the original magnetic field and the induced magnetic field would be the same direction. So I need to create x's inside that coil of wires. To do that, I have to have my thumb go clockwise. So the current in the case of this last one, E, would go around this way, clockwise. And that would create x's inside there. Because effectively I'd be switching this right-hand rule guy. I don't know if I have I don't know if I can switch them that way. You would put your thumb going around clockwise, and your fingers then would have to be pointed into the coil of wires into the page. So that's how you do the first 5 of those questions.